Hey guys, hi, this is Radhakrishna, and today we are going to learn about K-means data clustering algorithm. Now, before entering into K-means data clustering algorithm, we have to understand about different types of data clustering algorithm. So basically there are two types. One is unsupervised and another thing is supervised. Okay. So basically data clustering deals with, you have to classify the data, or you have to cluster the data into different parts by which represent similar data. Okay. I'll explain it to you clearly. So if you take an image, let it be a satellite image. So there are buildings, there are farms, there is a river, okay, and there are consider forest, okay, large amounts of forest. Now this is a data. In this image, each pixel has three values. If it is just a visual image, we have RGB. Each pixel has three values. Now this is a data. Every pixel is a data, and using this data we have to cluster this data into different classes, which might finally represent buildings or human constructions of concrete and water, and trees, farms and forests. Okay, so the data has to be clustered into different classes. Okay, that is the final aim of data clustering algorithms. And there are two types of algorithms, unsupervised and supervised, wherein unsupervised algorithms can cluster the data without knowing anything before giving the data, but supervised clustering algorithms only work if you have some information of the data before analysis. Okay, so K-means is a unsupervised data clustering algorithm, which means that if you have a data and you need not know anything about the data, only if you have a data you can cluster it into different classes. Now we're going to enter into what is this K-means data clustering algorithm and see it clearly. So let me take the similar example. So we have an image, okay, and by the way, this data clustering algorithms can work on any sort of data, multi-dimensional, single dimension, etc. But this is just for convenience. I'm just taking image because it is very clear if we talk about images in clustering. Okay, so each pixel will have three data RGB. So this image might be some X by Y size image. Generally it is 600 by 400 or something like that, but image can be any size. So X by Y image, and each pixel has three values RGB. Now before analysis of this K-means data, we have to guess or understand how many classes we are going to divide the image into, or how many clusters we want the data to be clustered into, because K-means is an algorithm where we have to know number of classes. Okay, so let us suppose that there are n classes, and for this example I am just taking 4 classes. Okay, so then we have to initialize 4 modules, which each module contains just 3 values, because here we had 3 values, here also we will have 3 values. Basically modules are just nothing but arrays, if you want to understand in computer terminology. Arrays which have 3 values. Just everything can be coded in data structures if you want, but understanding it will make you more perfect in coding them in arrays and stuff. So just for analog we will take them as RGB for everything, and also we will name those 4 modules as 1, 2, 3, 4. Okay, so these are 4 classes which exist in this image, and we want to classify each pixel into one of these 4 classes. Now entering into the algorithm, first off we have to initialize these values. We already have filled these values because we already know the image, what is the image, but we don't know what are these things. So we have to initialize these things, and most of the unsupervised algorithms initialize randomly, randomly, and then train using this data and cluster it. So randomly initialize. Okay, so first off you have to initialize them randomly, and before initializing randomly, one thing which you can do is to understand the ranges of these values. Basically they lie between 0 to 256, which can be normalized to 0 to 1. Any data in this world can be normalized to 0 to 1, so that initializing randomly will be easier. So if you have normalized all these image data values from 0 to 1, then you can also randomly initialize every value here Basically here there are 12 values, 4 into 3, 12 values which have to be randomly initialized between 0 to 1. Okay, now we have all these 12 values and all the image. What we have to do now is to basically classify this pixel into one of these 4 classes. Now here we are using distance classifications or distance mapper. So basically we have to calculate Euclidean distance between this module and the pixel to be classified, this module and the pixel to be classified, this module and the pixel to be classified, and so on for number of classes we have. Okay, so calculate Euclidean distance. Okay, once you calculate the Euclidean distance, what you have to do is to assign this pixel to the class where the Euclidean distance is minimum. Okay, so you have this pixel and you have calculated distance to this, distance to this, distance to and distance to this. Okay, and among this, whichever distance is minimum, that means the pixel is more closer to that set of values, so you are going to classify to minimum Euclidean distance. Now proceed in the similar way to the whole image. Okay, proceed to the whole data similarly. You have to classify every single pixel in the sum of these classes. Now what has happened here is basically we have classified everything randomly. We didn't know what sort of data exists. Now what you're going to do is basically change these values by understanding what we have learned from this data. Okay, now what we have basically now after fourth step is some random classes like class 1, we have class 2, and we have class 3, and everything is class 4. Just random classes because we have randomly initialized. Now we have to tweak these values so that this class mostly converges to some sort of data from class 1, and this class mostly converges to some sort of data from class 2, and so on. Okay, so for that what we are going to do is we are going to calculate the average vector. So this is a vector, right? So we are going to calculate the average vector of the pixels which belong to class 1. Okay, and replace that average vector here. Okay, and calculate average vector of class 2 and replace it in class 2. Okay, so calculate after proceeding to whole image or data, then calculate average vectors. Okay, and replace in module vectors. Now guys, what we have is a completely different module vectors and already an image. Now what we're going to do is basically repeat from second step. We are going to repeat from second step. After we have average vectors, in the second iteration what we're going to do is we are going to again calculate the Euclidean distance, again assign it to one of the class and based on the minimum Euclidean distance, and proceed to the whole image, and again calculate averages, and so on and so forth. You are going to repeat the same stuff till there are two conditions which can be met here. Two conditions. One thing is classes do not change in successive iterations. Classes do not change. So what this means is that whenever one time you have completed the image and classes came like this, and you have replaced them with averages, and then again you have classified, and if the image is same to same as this thing, so in further iterations the class are not going to change. So further iterations are a waste of time. So if the classes do not change in successive iterations, just stop the algorithm. Second thing, give a maximum number of iterations, like some 10,000 depending on your computer speed and the data size. This is just a 3-dimensional data, but clustering is basically done on dimensions like 10 or 4, 5, 6, and it's going to take a lot of time if you give 10,000 iterations for them. So it basically depends on what's your computer speed and processing speed, etc. So basically there are two conditions where you have to stop your algorithm. One condition is classes do not change in successive iterations, and the next condition is give maximum like 10,000 iterations, something like that. So after you do this, basically the data whatever you have will be unsupervisedly converge to some sort of understanding of the data which we have been fed. Okay, so this is a k-means data clustering algorithm which is completely unsupervised, and we're going to learn more of this data clustering algorithm. So if you have some comments on this video, just type it in the comments below. And if you want more from me, if you want to learn something else, just message me or comment me so that I will know and I will make a video for you. Thanks guys, subscribe to this channel if you like me, and you can also share this video with your friends who want to learn data clustering algorithms. So that's it for this video. Meet you in my next video. Bye. Hey guys, hi, this is Krishna, and today we are going to learn about K-means data clustering algorithm. Now, before entering into K-means data clustering algorithm, we have to understand about different types of parts by which represent similar data. Okay, I'll explain it to you clearly. So if you take an image, let it be a satellite image. So there are buildings, there are farms, there is a river data clustering algorithm. So basically there are two types. One is unsupervised and another thing is supervised. Okay, so basically data clustering deals with, you have to classify the data, or you have to cluster the data into different work. Okay, and there are consider forest. Okay, large amounts of forest. Now this is a data. In this image, each pixel has 3 values. If it is just a visual image, we have RGB. Each pixel has 3 values. Now this is a data. Every pixel is a data, and using this data we have to cluster this data into different classes, which might finally represent buildings or human